Alright, lesson 12.5, other rules of exponents. We are going to cover some properties that they discuss in chapter 12 but fit well with chapter 4 in our study of exponents. So the first one has to do when we have a quantity inside, we have something times another value inside parentheses. Notice they're being multiplied, raised to a power. So let's see what, if we were to expand this out, what we can arrive at. AB cubed is really the same as AB times AB times AB. It times itself 3 times. Now, because of our multiplicative properties, we can use our commutative property or associative property. We can rearrange the A, B, all of our multiples here into different orders and group them as we'd like. And when we do that, we have A times A times A in one set, and B times B times B in another set of parentheses. From there, we know that AAA is actually A cubed and BBB is actually B cubed. So if I were to bring this down, A times B cubed, we can see that the relationship between the two is whenever you have two values being multiplied together inside parentheses with the entire set of parentheses being raised to a power, really what happens is that exponent basically gets distributed in. It gets factored into both of them, multiplied into both of them. And so it becomes A cubed, B cubed. Now with dividing, it's the same thing. If we have two values being divided, A divided by B, raised to a power, that's really the same as that power being multiplied that quantity being multiplied 3 times. So A over B cubed is A over B, A over B, A over B. Now in our numerator, if we just focus on that, we have A times A times A. Our denominator is B times B times B. A times A times A is A cubed, B times B times B is B cubed, and basing it off of our original, we can see that again we do this similar thing. We distribute this raised to the third power, this cubed, into both numerator and denominator. Now the important thing here is that there are no plus signs or subtraction signs, because if you were to be adding A plus B or subtracting A and B, that's a completely different, that's something called FOIL that you'll study later on in your math career. But for right now, the first one was the power of a product property. To find the power of a product, find the power of each factor and multiply. So AB to the M is A to the M, B to the M. 3 times 4 squared is the same as 3 squared times 4 squared. And you could work it out. This is 12 squared, which is 144. This would be 9 times 16, which is also going to be 144. So either way, you get exactly the same answer. And then with the power of a quotient property, to find the power of a quotient, find the power of the numerator and the power of the denominator and divide. So A over B to the M is A to the M over B to the M. And notice they say B can't be 0 because you're not allowed to have 0 in the denominator. So let's try a couple, first with multiplying, then with dividing. I'm going to distribute this 3 in, so I get 2 to the third, x to the third. And because we aren't using calculators yet, but for some of these, doing 2 to the third should be rather reasonable. 2 to the third is 8, so we get 8x cubed. And that's our final answer. For letter B, we're going to distribute that cubed in again. I get 4 cubed y cubed. And 4 cubed is actually 64, so I have 64y cubed. That's my final answer. Letter C, I'm going to distribute that to the 4th power in, and I get 3 to the 4th x to the 4th, and 3 to the 4th is 81, so my final answer is 81 x to the 4th power. Letter D is a negative, so it's negative 7 squared b squared. And I put the negative 7 in parentheses because negative 7 times negative 7 is 49. So we get 49b squared. This negative, if you don't put it in parentheses, you're likely to forget about it, and then you're going to have the opposite signed answer, so you don't want that. So anyway, anytime you come to a negative, put it in parentheses when you're doing this. Alright, let's try the next page. Up here, we're going to continue with some of the dividing that we saw. I'm going to distribute this 7 into the numerator and denominator. I'm going to get m to the 7th over n to the 7th. And that's it. In letter B, I'm going to distribute the 5 into negative 3 to the 5th over k to the 5th. Now here's one, for time's sake I'm not going to work through it, but again, because we aren't using calculators, 3 isn't too bad to do to the 5th power, but something that gets a lot larger I'm not going to expect you to do. But you would simplify negative 3 to the 5th and get your answer. Alright, letter C, b to the third, b over c cubed is going to become b to the 3rd, or b cubed over c cubed. All I'm doing is distributing that 3 into the numerator and denominator, that cubed power. And in letter D, it's going to be x squared over negative 9 squared, and we know that negative 9 is actually 81, so x squared over 81. Final answer. Alright, let's move on down. Here's one more property. If we have a power being raised to another power, so a squared, all of that to the 4th. If we look at it again, expand it out, a squared to the 4th is really a squared, a squared, a squared, a squared, 4 times. So then we break it apart. A squared is a times a, so we have a times a, a times a, a times a, a times a. We end up with 8 a's, so our answer is really just a to the 8th. So looking back at our original, we can see that the relationship between these is that you're just multiplying 2 times 4 to get 8. Okay? So let's take a look here. That's what this says. Power of a power property. To find the power of a power, multiply the exponents. So a to the m all raised to the n is really just a to the mn. 7 squared to the 3rd is really 2 times 3, so 7 to the 6th. So let's try, all I'm going to do is multiply these two. I'm not going to actually expand it out, but I will make sure to use only positive exponents. So for instance, letter A, 10 to the 3rd cubed, there's really just going to be 10 to the 9th. And then you get your answer, whatever that would be. P to the negative 4 to the 5th, I multiply these two, I get P to the negative 20th. But we only want positive exponents, so I put that in denominator, it's 1 over P to the 20th. Letter C is 2 raised to the 3rd, all of that to the 4th power, so I'm going to multiply 3 times 4, I get 2 to the 12th. And again, multiply it out, get your answer. And then in letter D, 5 squared to the negative 2nd, again, even though that's negative, just multiply it like normal. We get 5 to the negative 4th, but I don't want negative exponents, so I write it as 5 to the positive 4th in the denominator. 1 over 5 to the 4th. Real quick, on some of these I've said you would multiply it out and get your answer. On a quiz or a test, because we aren't using calculators, I would not give you numbers that are going to, I mean with 10 it's different because it's the 0th power, it's not that bad. You just add the zeros, but for something like 2 to the 12th, I'm not going to give you something like that to evaluate, and if it is, it will say just leave it as an exponent. If we were using calculators, then, you know, obviously we would look at that, but I don't want to test you on just multiplying, multiplying, multiplying over and over and over. I think we're past that for right now, but I'm more concerned that you understand these exponent rules. Alright, last one, example 4, simplify the expression, write your answer in scientific notation. So, these are two separate terms, 3.1 and 10 to the 8th, so I'm going to distribute the 2 into both. I get 3.1 squared times 10 to the, and I multiply these, 8 times 2, 16. In this one I'm going to distribute that squared in. I'm going to get 2.1 squared times 10 to the negative 10th. And it says write my answer in scientific notation, so I can leave that negative exponent. I'm okay. Letter C, I'm going to distribute this cubed power into both, so I get 1.7 cubed times 10 to the, I multiply, negative 9 times 3 is negative 27. And that's that. And last one, letter D, I'm going to distribute this cubed into both of these. 4.5 cubed times 10 to the 7 times 3, 21. Okay, great job guys, and see me with any questions.